Hello friends, this is fourth lecture of thermal engineering in which we are studying steam and steam boilers. Okay, in the previous lecture we have studied different properties of steam, different charts, PV, enthalpy, entropy, enthalpy charts, or that is Molear chart. Okay, all these charts and properties of steam we have studied. Now let's see that steam generating machine, which is called as a boiler. Let's see that a boiler or a steam generator is a device made up of closed container or vessel constructed by steel used to create steam by applying heat energy to water until the water is converted into steam at required pressure. Okay, so this is machine in which uh, now it is a vessel constructed of steel in which water is converted into food at required pressure by heating. Okay, so this is the definition of boiler. If you want to go deep into this boiler, in third year mechanical there also these boilers are explained. Okay, but no need to go there. In this chapter also there are too many things given. Okay, let's see that. Although the definition is somewhat flexible, it can be said that older steam generators were commonly termed boiler and worked at low to medium pressure, that is 6.895 to 2068.4 to 7 kilopascal. But at pressure above this, it is more usual to speak of a steam generator. Okay, so in the previous generations, or we can say in the primitive stages of this boiler, the boiler was considered to be, or it was a device which were producing the steam at pressure. It is generally about 6 to, let it be to 2100 kilopascal. But nowadays this limit has gone too much high. Now it is also called as a steam generator according to SME. Boiler is defined as a combination of apparatus for producing, furnishing or recovering heat together with the apparatus for transferring the heat to made available to the fluid being heated and vaporized. Working principle of boiler. The basic working principle of boiler is very simple, that is easy to understand. And the boiler is essentially a closed vessel inside which water is stored, fuel is burned in a furnace, and hot gases are produced. These hot gases come in contact with water vessel, where the heat of this hot gas is transferred to the water and consequently steam is generated. Okay, these are the few boilers that we have to see. Okay, let's see their classification. Okay, let's see the classification of boiler. Okay, from after producing the steam, then the steam is piped to the turbine of thermal power plant, and then there are many different type of boiler utilized for different purpose, like running a production unit, sanitizing some area, sanitizing sterilizing equipment to warm up the surrounding, etc. Okay, so all this purpose this steam generator is used. Now let's see the different type of boiler. First one, according to the flow of hot gases and water. Okay, depending on that, this boilers are classified according to flow. First one is fire tube boiler. In this, fire in tube. Okay, this means fire tube boilers means what? Fire in tube. In this, the product of combustion or hot flue gases passes through the tubes which are surrounded by water which is to be heated. Okay, here are the uh, fire tube boilers: Kocharan, and Cornish, and Lancashire boiler. Water tube boiler. In this, water is passed through the tube and flue gases over the tubes. Example of Babcock and Wilcox. So this is the boiler in which water tube type is used. Then according to method of circulation, forced circulation boiler, or in which a centrifugal pump is used, high pressure boiler, and second one is natural circulation boiler. Okay, that means there is no use of any pumping device. According to method of firing, internally fired and externally fired, according to the position, horizontal drum type and vertical drum type. Then according to the number of drum and number of tubes, single drum, multi drum, one fire tube or water tube, or two or more than two fire tube or water tube, and according to steam pressure, low pressure and high pressure. This high pressure boiler in third year we are going to study. According to direction of hot gases flow, single pass, return pass and multi pass. Then according to nature of service, stationary boiler, then movable boiler or boiler, mobile boiler, locomotive boiler and marine boilers. Fuel used, oil fired and coal or pulverized coal fired. Okay, every aspect you are going to study in third year. So this overview is given in this second year, and two or three boilers are given. Let's study them. First one is fire tube boiler. As is indicated from the name, the fire tube boiler consists of number of tubes through which hot gases are passed. Okay, that means there is a fire in the tube or hot gases in the tube, and surrounding the tube there is a hot or water poured in it. Okay, these hot gas tubes are immersed into water in a closed vessel. Actually, in fire tube boiler, one closed vessel or shell contains water through which hot tubes are passed. These fire tubes or hot gas tubes are heated up the water and convert the water into steam, and the steam remains in the same vessel. As the water and steam both are in same vessel, a fire tube boiler cannot produce steam at a very high pressure. Generally it can produce maximum of 17.5 to kg per meter centimeter square, and with capacity of 9 metric ton of steam per hour. Okay, then advantages of is a fire tube boiler. It is quite compact and in construction. Then fluctuation of steam demand can be met easily, and it is also quite cheap. Let's see disadvantages. As the water required for operation of the boiler is quite large, it requires long time for raising steam at desired pressure. Okay, as water quantity is higher, so we can say the fuel is also required very high, and the to take that water from the atmospheric pressure to convert it into steam and then take it to the higher temperature, it's quite tough job. Okay, as the water and steam are in same vessel, very high pressure of steam is not possible. The steam received from fire tube boiler is not very dry. Now second one is water tube boiler. Converse of this, that means water will be in the tube and fire will be around the tubes. Okay, a water tube boiler is such kind of boiler where the water is heated inside the tube and the hot gases surround them. Advantages of water tube boiler. There are many advantages of water tube boiler, due to which this type of boiler are essentially used in large thermal power plant. Larger heating surface can be achieved of water tube. Then due to conventional flow, movement of water is much faster than that of fire tube boilers, and hence rate of heat transfer is high, which result into higher efficiency. Very high pressure in order 140 kg per centimeter cube square can be obtained smoothly. And disadvantage, the main disadvantage of water tube boiler is that it is not compact in construction. Its cost is not cheap, and sizes are difficult for transportation and construction also. Okay, because there are too many bends, and the designing is also quite difficult, we can say. Okay. Let's study between them the difference. Okay, let's study the difference between them. Fire tube and water tube boil. Few gases are passed through tubes. In this, the water passes through the tube. Steam generated at low pressure, and water tube steam generated at high pressure. Then rate of steam generation is less, and in water tube boiler, rate of steam generation is more and quick. Different part cannot separate it, so difficult to transport. Different part of it can be separated and easily for transport and erection. Inspection and cleaning is simple. Inspection and cleaning of this water tube boiler is quite hard, because the water in the tube is not very pure, or it may have some dissolved salt, which may form the scale on that inner wall of that tubing. So cleaning is quite difficult for this water tube boiler. The operating cost is less, operating cost is high, the bursting chances are less. Okay, but in this water tube boiler, bursting chances are high because there is a lot of pressure on the tubes. It can also cope with a sudden increase in load, but for shorter period. It is preferred for wide fluctuating load. It is not suitable for large plant, and it is suitable for large plant. These are the difference between fire tube and water tube boiler. Let's see if some fire tube boiler. We have given two fire tube boiler. Let's see them. First one is coach run boiler. It is a simple vertical. Okay, you can see the figure over here. See this fusible plugs to burn the fuel, cylindrical shell, then fire brick lining to reduce the heat transfer or heat losses, smoke tubes. Okay, from these tubes the gas or this hot gases pass through this. Okay, from all this tube these gases passes. Okay, then combustion chamber, you can see here this cavity is the combustion chamber, and the flue pipe. Yeah, this is flue pipe. Now here field check valve, then mud hole to remove this the ash which is deposited at the bottom. Then gates are also there, and firebox, ash pit, and then fire hole. Fire is initiated from here, and door if for cleaning purpose of this. Then smoke box, this total is called a smoke box, and this one is chimney. Okay, and surrounding all these tubes there is a water. Okay, here you can see the water, and the steam generated is, you can see here, water level indicator in this. Then manhole for cleaning purpose. Safety wall is also there to avoid any busting of the tank, that ground, and stop fall. Okay, from which we can take the steam outlet. Okay, so this is the layout of this coach run boiler, in which this is the fire tube of kind. It is simple vertical multi-tubular stationary fire tube boiler. The systematic sketch is shown in figure. It consists of cylindrical shell with dome shaped at the top, in which steam is formed or collected. Then the firebox is made up of single piece. Made of single piece with crown, has hemispherical shape. With large space for heating, the fuel is burnt on grate, and ash is collected and disposed of from ash pits. The flue gases from the furnace pass through the tubes and then escape to the atmosphere through the chimneys. While passing through the tubes, they reject the heat to water, and water gets heated, forming steam, which is collected in the ground. Okay, let me show you again. Okay, the fuel is burned at these places. Okay, here fire hole is there. Fuel is burned and the ash form is collected through ash pits and mud holes, whatever. Okay, then this hot flue gases pass through the tubes by rejecting its heat to the surrounding water, and these are exhausted to the atmosphere in this way by increasing the temperature of steam. Okay, now next one is another boiler is Babcock's and Wilcox boiler. The shape of crown is before that in that Cochran boiler. The shape of crown is hemispherical to avoid bulging effect due to steam pressure. A manhole is provided for cleaning the boiler. The capacity of boiler is 400 kilogram per hour, and the pressure built is about 15 to 17 bar. Okay. Now Babcock and Wilcox boiler. Let's see them. Let's see this. Let me show you that diagram first. Okay, here is the diagram. Again, this is also a kind of fire tube, but it is producing quite higher pressure than that previous boiler, that is Cochran boiler. You see all the component one by one. Okay, ash pit is here. That means fuel is burnt, and fuel cycle, you can see this flue gas cycle is here. Okay, in this way this flue gases passes by heating the water. Okay, so we'll say the fuel is burnt over here. Great, that means there is a mesh of metal on which this fuel is kept and burnt. Okay, then next one is fire hole, from which air for burning the fuel is blown. Okay, then grates furnace. Okay, this hole is furnace. Okay, this is the furnace. Then uh, uptake heater. Here is water. Okay, you can see the water intake. Wait. From here water enters and it is inclined at 15 degree. Okay, you can see. Then this passes over here. Okay, and then steam is collected above the surface of the water. Okay, and then the superheated steam is get collected. Okay, let's see more about it. Feed wall is shown, water level indicator. Okay, then pressure gauge for measuring the pressure of steam, safety wall, drum for carrying that steam and water, then superheated steam. Okay, superheater, this winding is what? Superheater. Finally the air goes from here. Okay, then inner tube, and then outer tube is here. Stop wall, baffles. Okay, to it are these are baffle. Okay, these are used for directing these flue gases. Okay, then water tubes, you can see this inclined at 15 degree. Okay, downtake heater side, and this uptake heater side, you can see. Okay, this is the general layout of, we can say, that Babcock and Wilcox boiler. These models of these both the boilers we have in our uh, lab, okay, of thermal engineering. I will give you their photos. Okay, in next few lectures. Okay, let's move to study that Babcock and Wilcox boiler. This is a horizontal, externally fired water tube, natural circulation type of stationary boiler. It consists of a drum mounted at the top. The front of rear end of drum are connected to header with short riser tube. this heater are connected by number of inclined tubes. The angle of inclination is about 15 degree to the horizontal. The water tube are straight and solid drawn steel tubes. The furnace is arranged below the uptake heater. The hot gases from the furnace are forced to move upward between the tubes. The baffles plate are provided between the tubes, act as a deflector, give the direction to flue gases, so the flue gases moves upward, then downward, and then upward to chimney, so that the maximum amount of heat is utilized by water, and the water gets heated and converted into steam. Here the principle of thermosiphon is used. As the water heated, the density decreases and the flow of water takes place upward. Okay, here this is the downside where water inlet is there. Okay, as water get heated, the water rises because its density goes on decreasing, and higher density water from this tank goes to this downward portion. Okay, then again it is heated, its temperature rises, and again it is go to the same tank, but you can see there are two layer. One is for steam and another is for here another is for water. Okay, from that, by AD means, or by preparing proper ventilation or provision, the that steam is taken from the that boiler, so that the maximum amount of heat is utilized by water, and the water get heated and converted into steam. Here the principle of thermosiphon is used. As the water heated, the density decreases and flow upward, so the steam generated is collected in the steam space of the drum. The steam then enter in superheater tubes, where it is further heated and then through then main stop valve and supplied to the application where it is required. Okay, you can see over here that is the capacity of this boiler is about 700 kilogram per hour at a 10 bar pressure. Pressure is also high in this case. Okay, you can see the layout again. uh, okay, so let's I will say let's stop here today. We will study Lamont boiler and Leffler boiler in next lecture. Okay, these are already for the third year, and though these are for third year, we'll study it. Okay, so thank you. We'll stop here today.